My name is Gary Petco, and I'm your Knox County Schools Mathematics Supervisor. Welcome to KCS Summer at Home Math video series that go along to your geometry packet that you can find online at our Knox County Schools website. This video goes along Geometry Section 4 on circles. I love this part because circles are all around us. I love when we can take physical features out there such as circles, triangles, and we put math behind it. And that's what this section is going to be working on. Oops. This section revolves around circles, but parts of circles, something called tangent lines, chords and arcs, inscribed angles, angle measures, and segments. We're going to use some of the vocabulary from previously learned geometry and then new vocabulary. The big ideas: reasoning and proof, measurement, and coordinate geometry. We've got tangents, chords, and arcs. We're going to define what each one of these are. Then we're going to talk about angles around circles. So the first is tangent, chords, and arcs. Those are segments that revolve around a circle. And then the second part, angles, the particular type of angles in a circle. And then circles in the coordinate plane. We're really not going to hit on this last part with this packet. That's more for they'll have it in your pre-cal calculus class, but we're going to work on these first few parts. Again, we've got vocabulary. Vocabulary that revolve around chords, inscribed angles, intercepted arcs, locus. Now, the numbers you see on the side relate to the geometry textbook you had, but you can just as easily find this vocabulary online as you Google it up in a math dictionary, or go to something like Khan Academy. And that'll help you answer these 5 questions. They're question starters to get your mind thinking about the topics that we're going to talk about today. Once again, the answers are in your answer key at the end of this packet. Let's talk about tangent lines. A tangent to a circle is a line that intersects a circle at exactly just one point. Now, you're going to use the word tangent a lot in your math career, but this talks about a tangent to a circle. So basically, it says it touches a circle and there's only one point, such as the ray PA. Now, keep in mind, this tangent could be a ray, it could be a segment, it could be a line. As long as that shape touches it in only one place, it's being tangent to it. So the tangent to a circle is a line that intersects the circle at exactly one point. Again, intersect could be touch. The radius to that point is perpendicular to the tangent. So, for example, the ray PA intersects right here at A. If I take and connect the point A to the center, which is O, that segment is automatically perpendicular to the ray. Now keep in mind what that's going to start thinking about is perpendicular lines, maybe triangles, right triangles. Start thinking about that. And then from any point outside of a circle, you can draw 2 segments to a tangent. From any point outside of a circle, you can draw 2 segments tangent to a circle. These segments are congruent. So that means if I take the letter P, which is a point way outside the circle, and can take P and connect it to a place where it intersects the circle, and then on both sides, then automatically means these 2 segments, AP and BP, are congruent. We're going to use that concept to answer this question. PA and PB are tangents. That automatically means that these 2 segments are congruent. Find what X is. The radii, that means the radius more than 1. The radii are perpendicular to the tangent. Bam, bam. So if I'm trying to find that out, here's what I'm going to do. Ooh, look at what I've got right there. If I'm trying to find, I want to find angle C, or angle X right there. I got to figure that out. Well, look what I've formed. AP, PB, BO, and OA, that forms a 4-sided figure. What did we say about a 4-sided figure before? We can find the angles of all the sum of all the angles inside. We know the sum of all the angles add up to 360 for a quadrilateral. So if that's perpendicular, that means from our previous rule that the tangent line, the radius is perpendicular. That means this angle is 90. Down here, OBP is 90 degrees. So if all 4 angles add up to 360, that means our unknown angle plus 90 plus 90 plus the 40 given have to be 360. Got a simple equation, allows me to solve for X, and X is 140. I'm going to use that concept along with these other 2 to answer questions 6, 7, and 8. What about chords and arcs? A chord is a segment whose endpoints are on a circle. Basically, it's inside the circle and just touches sides of the circle. We've got chords right here. Chords right here. Now, this little segment right here from the center to the other chord is not a chord because it doesn't go all the way to the end of the circle. So it has to touch two different places in the circle. It's called a chord. Congruent chords are equally distant from the center. So if I tell you these two chords are congruent, they must be the same distance from the center. A diameter that bisects a chord that is not a diameter is perpendicular to the chord. In other words, once I draw a diameter or a radius perpendicular to that chord, it bisects it. Well, that's a segment bisector. So how can I use that information? What is the value of angle of side D? That little bitty segment from B to C. How can I find that? Well, since the chord is bisected ACB, it bisects it, and I know it bisects because those two sides are equal to 12. So if it bisects it, that must mean that has to be a right angle. Ooh, if it's a right angle, look at this. I could draw, let's see, how could I do that? I could take, and the radius is 13 units. So if I were to take a segment and draw it from B to A, that's what they call auxiliary. You get an auxiliary verb in English. It's a helping verb. Auxiliary line is a helping line, a line that helps us solve a problem, and it's not going to it's not going to defy the rules of math. I could easily draw a segment from B to A. It happens to be the radius. We already know that the radius is 13, so if I draw it from B to A, it's still going to be 13. So if that radius is 13, I've got a right triangle BCA I could form. Once I draw a radius in, where the hypotenuse is 13, a side is 12, I use the Pythagorean theorem to find the unknown amount, which is D. I'm going to use this concept right here to help me solve questions 9 through 13. Okay, the next part, inscribed angles. Inscribed has the word in, an angle inside a circle. Excuse me. An inscribed angle has a vertex on the circle and its sides are chords. In other words, the vertex touches the circle and it crosses over and hits the circle in two different places. Once that inscribed angle is created, it produces an arc, a small section of the circle, AB, right here where I'm circling. That is called an intercepted arc that intercepts. And we've got the inscribed angle. There's a relationship. An intercepted arc has an endpoint on the side of the inscribed angle and the other points on the interior of the angle. So in other words, inscribed angle forms an angle and it gives an intercepted arc. So how does that really help me out? The measure of an inscribed angle is half the measure of the intercepted arc. So if you tell me that intercepted arc is, for example, 10, that means the angle that intercepted arc is formed by is 5. There's a relationship. So they're asking, what is the measure of PS? Measure with an arc over PS. Measure this PS right there. What is that? Well, and then what is the measure of angle R? Well, let's look at this. Notice what PS is. PS is an intercepted arc formed by this angle PQS. And PQS is 60. And it says the measure of the intercepted arc is half the measure. The measure of the intercepted angle is half the arc. So if that's 60, it's half of this arc, or in other words, the arc is twice the angle, that must mean that has to be 120. And then what about angle R? Well, let's find angle R and see what it creates. It connects S and P. That happens to be the exact same intercepted arc as the previous. So if that intercepted arc is 120, the angle that forms that intercepted arc is half of that. That's equal to 60. I'm going to use that concept to help me solve 14 through 17. And then last and definitely not least are angle measures and segments. Essentially what this is going to give me 3 different sets of formulas. And depending on what type of information I'm given in the circles. we've got a secant. A secant is a line that intersects a circle at 2 points. For example, this segment right here from B over, that's a secant because it intersects it at one side of the circle and somewhere else. If it intersects in one place, it's a tangent. It intersects in 2 places, it's a secant. We've got a relationship. 2 chords. If I've got 2 chords, because remember chords where it's inside the circle and intersects at 2 places, 2 chords that are cut into 2 pieces, I have the products AB is equal to CD. AB is equal, so in other words, there are two small parts. The product of those 2 small parts is equal to the product of the other chord that intersects it. Here, if I'm given this type of figure where I've got a secant, 2 secants, I can find the measure of those angles using this formula. If I've got a secant and a tangent, I can find the measure using this formula or the measure of an angle. So we're going to read the problem. You read the problem of these 4 and then look, see which situation am I given. What is the value of x? Well, x, that diagram looks like this middle one. So I'm going to see what information is given to me. I'm given an x and a w, and I'm given a y. I'm trying to find z. So I'm going to use this formula right here. X plus 10 times 10 is equal to 19 plus 9 times 9. I'm using that formula, solve that equation, and I get x is equal to 15.2. These 3 relationships for angle measures, segment measures will help us solve 18 through 21. Folks, I wish you luck on this. Use your answer key. Use your various resources on the Knox County School website to help you out. We have many resources that can help you out, and I wish you good luck with this last section of geometry. Let me leave you with another great quote from a mathematician, Katherine Johnson. I'm always interested in learning something new. Geometry students, I hope that's how you always are with your math. Always thinking, what's something new I could learn? It's kind of boring to learn something we already know. I know it's comfortable. I know it's comfortable to see things we already have seen before, but the fun is when you start to learn something new. Good luck and enjoy this segment of geometry.